Before we discuss repairing compressor valves, we need to talk about the three types of valves you may come across: feather, plate, and channel valves. All three types of valves work in much the same way, even though their construction varies. The basic parts common to all three are a valve seat, one or more movable parts usually held in place by spring tension, and a guard or stop plate. Here's how the parts work together in a discharge valve. As the piston compresses air in the cylinder, the pressure of the air rises, overcoming the spring tension and the air pressure in the discharge piping. When the piston reverses its stroke, the air pressure in the discharge piping and the spring tension in the valve overcome the air pressure in the cylinder. This pressure difference closes the valve, preventing air from returning to the cylinder. Keep in mind what we just saw was the operation of a discharge valve, but inlet valves work identically. Their operation is simply the opposite of the discharge valve. Well, now that you know basically how compressor valves work, let's look closer at each type and explain how it works in greater detail. We'll start with the feather valve. Now this example is two valves in one, an inlet valve and a discharge valve. The parts of this typical feather valve include a valve seat with two ports drilled through it and two feathers, one of which is visible here. The feathers are flexible strips of steel attached to one end of the seating surface by rivets. The upper feather acts as a discharge valve. The lower feather, the one you can't see, covers the other port and acts as an inlet valve. Above the seat and the feathers is a guard plate that contains an inlet port and a discharge pipe. On a downstroke, the pressure differential across the valve causes external air pressure to push open the lower feather, allowing air into the cylinder while holding the upper feather shut. On an upstroke, the pressure in the cylinder shuts the lower feather and pushes the upper feather open. Our second type of valve is the plate valve. It contains a valve seat, a guard plate, and a movable part called a valve plate. The valve plate is held against the seat by a series of coil springs. Now in this configuration, the air path between the inlet and the outlet is blocked. On an upstroke, air pressure in the cylinder overcomes both the pressure in the discharge piping and the spring tension, lifting the valve plate and unblocking the air path of the discharge piping. The motion of the valve plate is guided by two pins on the valve seat. After the compressed air in the cylinder escapes, the combination of the pressure in the discharge piping and spring tension is great enough to overcome air pressure in the cylinder. This causes the valve plate to shut, closing off any backflow of compressed air from the discharge piping. Now, our third type of valve is the channel valve. This is the type installed in the compressor that we're going to overhaul. First, let's look at its parts and then see how the valve moves. A channel valve is made up of three basic components: a valve seat, a stop plate, and the movable parts, the channels. In addition, it has channel guides and leaf springs. The channel in a channel valve acts like the feathers or valve plates in other valves. The channel sits on the valve seat and blocks the air path between the inlet and the outlet. A leaf spring holds the channel against the valve seat. The stop plate has raised areas that hold the leaf spring against the channel. The channel guide holds the channels and directs its up and down motion. Before we can fully understand how this channel valve moves, we need to look at exactly how the valve is positioned in the casing. There are two parts which hold the valve in place: the inner cover, which screws to the valve, and an outer cover that bolts to the cylinder's casing. The outer cover has a bolt which is threaded through the cover and presses on the inner cover to hold the valve in place. There's also a nut on the bolt, which prevents air from leaking out around the bolt. Since this is a discharge valve, the valve seat faces toward the cylinder. The seat of an inlet valve faces away from the cylinder. Now, if you remember this point about the orientation of the seat, you'll never make the mistake of reversing channel-type discharge and inlet valves. Once this valve is properly placed in the casing, It works much the same as the feather and plate valves we've seen already. On an upstroke, the piston reduces the volume in the cylinder, compressing the air until its pressure is greater than the pressure in the discharge piping. Pressure in the cylinder then overcomes the discharge piping pressure and the spring tension, lifting the channel and allowing compressed air to flow out of the cylinder and into the discharge piping. After the air in the cylinder escapes, the pressure in the cylinder equals the pressure in the discharge piping and the channel closes. Well, now that we've seen the parts of a channel valve, how they work, and how the valve is held in place, we're going to take a look at the removal, inspection, and replacements of a typical channel valve. Before you begin any work, you must be sure to check that the compressor has been properly depressurized. To make sure of this, check your pressure gauges. If your compressor has any vent lines, be sure they're open to ensure that all pressures bled off. It's also necessary to make sure that all your plant's tagging procedures have been followed. To ignore either one of these precautions puts you in danger. If there's any pressure left in that compressor when you begin work, any one of its components could turn into a flying missile. When you have made sure that everything is in order, you can begin. First, to remove the valve, you have to break the nuts holding the outer cover free and remove them from their studs. When the last nut's been removed, lift the outer cover off and set it aside safely out of the way. Next, lift the valve out and remove the gaskets. The inner cover is fastened to the valve by 2 screws. After you remove the screws, you're ready to take the valve apart. To take the valve apart, you remove these 2 screws on the valve seat. But be careful that the parts inside the valve don't fall out. If you're not going to replace the channels, mark them so you can be sure to replace them in the correct channel guides. Now this is important because each channel rubs against its guide in a particular way, forming a wear pattern. The friction between the parts causes this. Changing channel positions could interfere with the efficient operation of the valve. The next step in this operation is to pry out the channel guides. Once that's done, you're ready to clean all the valve surfaces. To do this, you use a solvent and a wire brush or scraper, but it must be done carefully. Avoid gouging the metal while scraping, and be sure to use an approved solvent. For example, do not use a flammable solvent. Heat from the action of the compressor could cause a solvent to ignite or possibly explode. When cleaning the surfaces, check for excessive carbon buildup. The carbon should be in a thin, even layer. Now, if you notice any chunks of carbon, too much oil may be getting into the cylinder. If this is the problem, the cylinder lubricator should be adjusted to reduce the oil flow when the compressor is started up again. This might also be caused by too much heat in the affected area. If this is the case, the flow of cooling water through the water jackets should be increased. After cleaning all the valve parts, inspect them carefully for any signs of wear, such as chips along the edge of the valve seat where the channel goes. If you find any wear along the seat, grind it to ensure a flat seating surface for the channels. Surface grinding is done on a grinding machine. It actually removes a fraction of the metal surface, and it tends to leave tiny scratches in the surface of the metal which can interfere with the valve operation. So it's necessary to lap the surface to remove these scratches after the grinding is completed. Lapping is done by applying a thin coat of lapping compound to a lapping block. Then you place the valve seating surface down and apply light pressure using a figure 8 motion. After cleaning the lapping block, this procedure is repeated using progressively finer grades of lapping compound until you've got the right finish. Then all traces of lapping compound must be removed. Otherwise, it will interfere with the next process, bluing. Bluing is the process used to check the seating surface to be sure that there are no high or low spots. To do this, you apply a thin coat of bluing to a surface plate. Then place the valve seating surface down on the plate and turn it 1/4 turn. Remove the valve and check the seat. You should see a thin,
even coat of bluing. Areas of uneven bluing indicate that the surface isn't flat yet, so it should be lapped and blued again until it's right. The next step is to thoroughly remove all traces of bluing. Once this is done, you know you have a good seating surface. Then you can start to put the valve back together. The first step is to attach the channel guides to the valve seat. Then you replace the channels and their leaf springs. Make sure each channel is replaced in its proper guide. The last step is to put the stop plate in place and replace the screws that hold the valve together. Remember that if you performed any resurfacing, the old channels and springs must be replaced. Otherwise, they won't seat properly due to resurfacing. Before you can put the valve back into the cylinder, though, you have to check the channel lift. Excessive lift could cause early failure. Now, we've removed some metal from the seating surface by grinding and lapping, and this would increase the lift of the channel. To check the lift, you use a dial indicator. Mount the indicator so that its stem touches the channel. Set the indicator so that it reads 0. This gives you a reliable reference point for taking the readings. Slowly press down on the channel, forcing it open. Be careful not to bump the valve or the indicator. The amount the indicator moves indicates the lift of the channel. If the lift of the channel is not within the range of specifications set in the manufacturer's manual, you have two choices. You can either replace the valve or machine the step that the valve seat sits on. After you've reassembled the valve, the next step is to refasten its inner cover. Now, you can begin the next phase of this procedure, putting the valve back into the casing. First, the two valve gaskets must be replaced. One of them provides a seal between the valve and the cylinder. The other provides a seal between the outer cover and the casing. When placing the valve into the casing, make sure that the inlet valve goes into the inlet port. If you make the mistake of putting the inlet valve into the discharge port, the valve won't work, and it could cause excessive pressure that would damage the valve and piston rings. Another thing to watch out for when you're putting the valve into the casing is that the channels are lined up with the piston so that no turbulence is created.